So I had kind of shown this off in a couple of videos before where someone had sent me a box of 16 chassis to work on. And I got the first 5 that were considered a priority, got those done, sent those back to the owner. Well, that left 11 of them to do, and I've kind of slowly worked my way through them. Most of them didn't really have anything of note, just needed reflows and cap kits and flybacks. Nothing was out of the ordinary, except for the very last one that I did previous to this video, the video prior to this one, where I talked about the bad solder pads and the oxidized pads, and R97 was smoking. That was of note for sure. But most of the rest of them just needed cap kits, reflows, flybacks, the normal stuff. Nothing of note to really make videos on. However, we have 3 left. There's 2 left in here, 2 7000s. And then over here we have a 25-inch K7000A. Another K7000A. There's a string of them I've had here recently on the channel. And now that I think about this, I forgot I need to turn this back out. Okay. I've had a string of these on the channel as of late, and this one was in really good shape. It already had a cap kit done. Of course, can't change a flyback out. We know that by now. It was very clean. It already had a cap kit. All the solder joints looked pretty good. I did hit a little reflow here and there, but for the most part, everything I inspected was fine. Nothing even remotely close to how bad it was on the previous one to this one in the video prior to this one. Nothing even close to that. So it was actually in good shape. I did hit a few solder joints that looked suspect, but otherwise not too bad. So I went ahead and got it all tested. I tested all the components, HOT, voltage regulator, all the resistors, everything tested good, all the normal stuff. So I went ahead and powered it on, and it powers on. And it sounds great. Listen, here we go. 1, 2, 3. Powers right up, good solid sound, nice high voltage energization. However, we are met with, dun dun dun, collapse yet again. I just fixed a 7000A with collapse. So this should be interesting. Let's see if we can figure out what's causing collapse on this one. And then we'll see what becomes of that and if we can get this fixed. So I was not expecting to see this because of how good a shape this was in and all that. It didn't look very molested, or the cap kit got put in very well. No damaged joints or anything like that, busted traces that I could see. So I'm going to go ahead and take this down, or tear it down I should say, and see if we can get this figured out and see if we can determine what the actual issue is. So let's get it off the tube, tear it down, get it on the overhead, and go through and see what we can find. So when you're dealing with vertical collapse, it doesn't matter if it's a K7000 or K7000A, 19-inch, 25-inch, doesn't matter. It's generally one or more of 5 things. R91, R92 are way out of spec or open. D13, D14 are shorted, or the vertical IC is bad. It's usually 98% of the time one of those 5 things. So let's go ahead and see if we can figure out if it's any of those 5 things on this one. And we will start by getting the meter here. And let's see, on the 7000A, I've mentioned before that D13, D14, R91, 92 are in different locations than the base model 7000. But I got a few videos on collapse for the regular 7000, so we're not going to go into detail of the location differences and things. But for now, R92 and D14, I think, are down in here. You have to get to them from the bottom side. Right here is R92, this guy right here, and right underneath it there is D14, I believe, is 14. And then up here is R91, and then get out of here. R91 is that resistor there, and D13 is that diode right there in front of it. So you have D13 there, and R91, and D14, and R92. Is that 13? I think that's 13. Yeah, so that's the way that is. So we have to get that from the bottom side, or the back side. So our resistor is right here, and it translates to these 2 pads right here. Okay, so here is our R92. I got to get in frame here. All right. So R92 and R91 should both be 1.2 ohms, give or take. And if we look here, our resistor is actually right here. Oops, sorry. Let's go to here and we get 1.4. So R92 is good. D14. D14 appears to be good. That's a normal reading. It reads a bit lower in circuit here than your normal +5 voltage drop, but it's not shorted. It's not open. So D14 and R92 are good. So we have to go over here to R91 and D13. R91 is here. These two posts here is R91. Again, we're looking for 1.2 ohms, give or take. And 1.5. D14 are these two pads. And interesting. So it's none of those. That's all good. Next step is our vertical IC, which is this guy right here. And normally only pins 1 and 5 should be shorted to ground. And if we go here, can I do this? Let's just flip it around this way. Okay, and when you normally read this vertical IC, the standard K7000 is a bit different, but on the 7000A, pins 1 and 5 are normally tied together. There's normally a jumper across here, and if you see here, it's got a factory mod here. There's normally a jumper across here, from there to there. See that jumper location? Well, they take that out of there, put a capacitor in there with a resistor, and tie it to here. So normally that jumper pins 1 and 5 together, but they do a factory mod for this thing, and that's no longer the case here. But so that means that only really pin 1. This is our ground pin right here. If any other pins read to ground besides this one, we can bet that our vertical IC is bad. So if we just go to ground here, and we'll go to our continuity mode, pin 1, ground as expected. Pin 2, nope, that's not good. Another indication here is we have 0 ohms to ground. And this pin here, if this pin was actually supposed to be ground, it'd be 0 ohms as well. But we can see here that it's 2.1 ohms. That is a good indication that our vertical IC is actually shorted. I don't think I have one of these. If we go to the rest of them, nope, 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 nope. Disregard that, that's fine. See, it goes to 0, or out of limits. OL, if you didn't know, OL is out of limits. Yeah, well, I think we've got a shorted vertical IC because our ground is 0.0, 0.1, that's a direct short to ground. If pin 2 was supposed to be ground, it would be 0.1 as well, but it's 2 ohms. So we've got an internal short to ground through internal resistance on the... so what we have to do to verify that is we have to remove the vertical IC out of circuit and see if pins 1 and 2 are still shorted together. If they're not, we got to figure out what's shorted on the chassis. If they are shorted together, I got to find myself another vertical IC. I don't even know if I have one of these. I think I have in my stash here. Dang it. I have a 7000A in the stash of parts, but I've already robbed the IC, it looks like. That sucks. I don't have any more 7000As. Well, hopefully it's not the IC. So let's get this out of here and see if we're dealing with an actually shorted IC or something on the board. So, wrong way. And I gotta turn this around here. Okay. Okay, all of our pins are free except our ground. Now our ground is free. Okay. So let's see if we can get this out of here. And I need this tiny bit here. Really? Come on. Well, we'll have to get the... Can I get the nuts from the back side? Nope, probably not. Well, that's why we have this handy. Another ingenious design. I have an idea. Let's put this in here with screws that you can't freaking get off. There we go. By the way, this is a good way for you to know whether you have a 25-inch or 19-inch 7000A, because the 19-inch 7000A has a little metal clip, kind of like this one here. It's a little clip that clips over the IC, but on the 25-inch, it's a tall heatsink like this that it's screwed to. So that's a good way for you to be able to tell whether it's a 19-inch or 25-inch 7000A. Also, I'm pretty sure that the 19 7000A doesn't have this mod here that removes. You can see here where this jumper used to be, they cut it out, and there's normally a jumper that connects pins 1 and 5, and this is a vertical mod of some kind, but pins 1 and 2 should not be shorted together. So regardless of that, if you ever come across one where 1 and 5 is shorted together, it's supposed to be because of that jumper there. If you look on the back, you can actually see that jumper would go from this point to this point, and it jumpers pin 1 and pin 5. 1, 2, 3, 4, 5. Yeah, so that would be normal if you get that reading. That's absolutely normal and nothing to worry about. Can I break this one loose here? Hey, it's a miracle. Sulu, look! The sun's come up. It's a miracle. Don't worry, boys, your secret's safe with me. Look at that, right out. Hot dog. Okay, let's test pins 1 and 2 on the actual board here. Continuity mode. And let's see. Nope. Open. Alright. This is a Alpha November 5521. So if we go to pins 1 and 2, shorted. Gosh darn it. Interesting though. If we read to the back of the frame here, we get some interesting readings. We get 95 ohms to pins 1 and 2 to the frame. I just find that odd is all. But regardless, pins 1 and 2, pretty certain we're not supposed to have those two shorted together. So I don't know for sure. Only way to know is to get another vertical IC and see what we get. I'm wondering if I shouldn't just go ahead and slave in one from a regular K7000 just to see if I get partial deflection or anything, because the last video I did on this, I made the determination that the regular 7000 IC was not compatible with the 7000A because I still had collapse after replacing the IC. I put the original one back in and my collapse went away. So I don't know for sure, but in the past I've done similar testing, and when I had full collapse, I'd put the 7000 in on the 7000A, and I would get partial collapse because of that jumper that goes across 1 and 5. So I don't know. I want to try maybe for testing, but let me see if I can find, because when you look up this on Arcade Parts and Repair, it's its own individual IC. It doesn't say it's compatible with any other ones. It doesn't say that the LA ones for the regular 7000 are compatible. It doesn't cross-reference. I think this is its own individual circuitry type of chip. I don't think you can throw a regular 7000 one in here. I don't think so, but it may have been modded. This may be a mod to allow you to do that. That's why that jumper has been replaced. So I let in this for the sake of troubleshooting and the sake of experimentation. I've got a couple of, let's see here. I actually have in my bag of 7000 parts here. I have got, wherever they went here. Here it is. There we go. I've got some vertical ICs here. So I've got the two main styles here that the 7000 uses. This one here and the LA 7833 is the more common one, this one here. And I've also got, yeah, two of the LA 7833s. So it's the same number of pins and the same style, but as you can see, it's 2 versus 1 on the mounting holes. Interesting. Yeah, that's just the type of heatsink. Okay. Well, I think for experimentation purposes, let's toss one of these 7833s in there and just see what happens. What's the worst that could happen? It could short this one. So I guess before we try this, let's make sure none of the pins here are shorted, at least to the frame here. Okay. That's the ground. So there's our pin 1. If we go to this one, it only read 95 ohms. I think there's something internally bad with this one, because that should be our ground. How about this one? That's probably a different circuitry. Yeah, so something's going on with this one. But there's our ground, and pin 2 is not shorted to ground, because this should be ground. This should go right to the frame here, if I'm not mistaken. I don't have one of these on hand, unfortunately. Darn it. So let's go ahead and just toss this in here and see what happens. Maybe we'll get lucky. I know it doesn't work on the 19-inch, but maybe the 25 it'll work, because the one I just fixed previously had that jumper there. It didn't have this mod on it. So maybe that mod allows you to use this 7833 instead of the AN5521. Maybe. I don't know. Well, let's put this in and see what we get. Okay, we'll scratch that idea, because shortly after I made that statement about trying to slave in a 7833 just to see if it worked, I kind of cut away and thought, well, you know, I better make sure that they actually are the same when it comes to functionality, and they're not. I've had a 7000A in the past where I had full complete collapse like this, and it had the AN5521. I've never seen a 7000A that didn't have the AN5521. I'm sure there's probably some out there that have been modified, but for all I know, all the ones I've ever had come across the bench has all been the AN5521. So I thought I better stop and make sure that the LA7833 is compatible, and it turns out that it's not. Pins 6 and 7 are flipped. Pins 1 through 5 are identical for this one to this one, the 7833 to 5521. 1 through 5 are the same, but pin 6 on this one actually goes to 7 on here, and pin 6 on this goes to 7 on here. So 6 and 7 are swapped. So you could put one of these in your 7000A, and it would give you partial collapse, maybe 2 or 3 inches of image, but it still would be collapsed and folded over because pin 6 and 7 are swapped. And I'll show you the data sheet here in a minute by what I mean. But if you have a 7000A with the AN5521, you can only replace it with the 5521. It's the only one that's compatible with the way that the chassis is designed. And I'm pointing over here because I got the chassis sitting over here. So unfortunately, yeah, you have to use the AN5521 for the 7000A, and I ordered 3 of them here. I actually ordered 3 of these. There's 4 different vertical ICs that you can have on a 7000. The 7000A is exclusively AN5521, But the standard 7000 can use the LA7831, the LA7833, or the Charlie 1378 Alpha. So there's 3 different kinds that you can use here. So if you have a 7000 with the 1378 Alpha, I'd recommend putting back in the 1378 Alpha, and so on and so forth. So the 7833 and the 7831. So there's 3 different kinds of vertical ICs that the 7000 uses, and I'd recommend replacing them with the correct one. So I went ahead and ordered 3 of each one just for future use. But for this purpose, we're going to have to use an AN5521. So I'll get one of these out of here so we can do some testing and comparisons here for what the pins read and such. But before we do that, let's look at the spec sheet, and I'll show you the difference between the 7833 and the 5521. So if we open this up here, you can see that this is the 5521. And if we zoom in here, you can see that pin 1 through 5 are the same: ground, output, supply, voltage, input, and trigger. But pin 6 is pulse amp output, and pin 7 is VCC. So now if we go to the 7833, you can see that ground, vertical output, vertical output supply, vertical output pin, input pin, oscillating pin, but then pin 6 is VCC, and pin 7 is pulse amplifier output. So pins 1 through 5 are the same, but on the 7833, pin 6 is the VCC, and pin 7 is the pulse amp output. And on the 5521, 7 is VCC and 6 is the pulse amp output. So these 2 chips have pin 6 and 7 backwards. So that, it won't destroy anything. It'll just, for some reason, when you put one of these in place of one of these, you'll have partial, like maybe 2 or 3 inches of deflection because of that being backwards. So they're not compatible. You can't make it work. If you swap those pins, you will destroy the chip, because you don't want to put VCC into the wrong pin. So yep, that's the reason behind why I kind of cut away there and decided to just cut to this tutorial here, if you will. You absolutely have to use one of these. If you have one of these, you can't use anything else. There's nothing else. They're all different. So Arcade Parts and Repair has those in stock, has these in stock, so no issues trying to get one. But if you recall, we had like what, 50 some odd ohms to ground on pins 1 and 2 of our bad one. So let's just check again here. So here is the one we removed, and if we test it, pin 1 to the frame, well, 100 ohms. That's not right. Pin 2, 100 ohms. So we have 100 ohms to pin 1 and 2 to the frame. That's absolutely not correct. If we go to the good one we just ordered, pin 1 to the frame, 141, pin 2, see there, 3 megohm. So there you go. Pin 1 is the ground, I think. So 140 ohms to ground is fine. But pin 2, 3 megohm. That's what you're wanting. You don't want any of the pins to read directly to ground. Pin 3, 3 megohm, 4, 7 megohm, 6K, that's okay. 6 megohm, 3.1 megohm. So yeah, our problem is our pin 2 is shorted to ground. Say 102 versus 3 megohm. So we absolutely have a bad vertical IC. So let's just go ahead and get this brand new 5521 installed and see if that fixes our problem, because we've already gone through and verified that we don't have a bad R91 or D13 or R92 or D14. What else did we test? It's been like 5 days, I can't recall. I didn't go back and look at the footage, but I think that's the major causes for vertical collapse would have been the vertical IC R13, I'm sorry, D13, R91, and D14 and R92 are usually the major causes of collapse. And we already checked all these and those were good. And then we got to the IC and found pin 2 shorted to the frame. So that is most likely our problem. So let's go ahead and get this installed
and then we'll get it back on the tube and cross our fingers, see what happens. Okay, and just like that, our new vertical IC is installed. Right there. Here is our old one that was bad. So now with this new one in here, let's test to make sure pin 2 does not ring to ground. I've got this ready to go here. Let's actually zoom out, sorry, wrong way. And not sure how I'm going to be able to do this. Let's see. We have to go out more here, I guess. It's always precarious trying. I don't have a. This is the amateur channel. I don't have digital readouts and stuff like other professional guys do. So, sorry. Just me, my meter, and a chassis is all it takes. All right. So if we recall before, let's just pick a ground here. Let's go right here. Pin 1 obviously is ground because it's attached to the ground plane here. So pin 1, 0.4. Pin 2. 1.3567892. Yep, not shorted anymore. Actually, you can't see, but it's actually K. It's K ohm. There you go. So I'm fairly confident that that's going to be it. Let's go back to. There's pin 3's mega ohm. 4 is 1500 with 1.5K. I couldn't see because of the glare. Sorry. 5.8K, pin 7, 1 mega ohm to ground, that was pin 6, sorry, pin 7's 1 mega ohm to ground. So I think we're good. Nothing left now but to try it. So I'm absolutely positive that this is either the cause, the problem, or, oh, sorry, definitely a contributing factor. So let's see if our situation has improved with the replacement of the IC and see where we're at. If we get full deflection, hey, we'll call it good. If not, then we'll keep going. At least it should be somewhat better now. So let's get it hooked up and see what it looks like now. All right, so we have our old vertical IC right here. New one's installed, everything's hooked up. We got anode, neck, yoke, ground, video, power, and there's no remote board. They're all installed on the chassis. So let's turn on our test pattern generator. My high impact football, or my super high impact board, is giving me fits, so I have to use a generator for now, which is fine. So fingers crossed here. Let's see what we get. 1, 2, 3. Okay, comes right on. That's good. What do we have? Oh, look at that. Something else is wrong. Well, oh crapola, as they say. Well, what happens if we adjust vertical size here? Okay, well it stops flipping around, but partial collapse now. Interesting. Well, we know that we got the right IC in there, and nothing's wrong with it. We'll go test it again. Maybe there's something else in the circuit, but now we have something going on here. Interesting. Well, let's test to see if we get our voltages. I'm going to cut away here and let's get set up. I'm going to do some testing on the voltages and see what I get for our voltage readings at the IC. So hang on a second. Well, I tell you, it's been a crazy hour or so, the last hour for me. So we shut this off and we still had collapse. It was partial collapse. Before we had total complete collapse, we changed the vertical IC because it was bad. We put a new one in and then we had partial collapse. Well, that's when I last left you. We shut it down. I went to take the chassis out and I grabbed the heatsink here and it was so hot that it burned my hand. It's not that bad, but it burned my hand. Like, that's not supposed to be that way. So I took the chassis out and checked it, and sure enough, our brand new vertical IC that we just put in was also now shorted the same exact way, 100 ohms to pins 1 and 2. So the same thing that happened to our original happened to our replacement. So if you follow the trace from pin 2 of the IC, it runs through a couple of resistors and goes right to IC2. IC2 being that guy right there. IC2. Get out of the way, you stupid wire. This guy right there. So the last K7000A I had, the very last one of these that I did, I think it's 2 or 3 videos back, I can't recall. It also had vertical collapse, and it was a bad IC2. I think, as a matter of fact, the words I used to describe IC2 when I took it out was haggard. This one wasn't very haggard. It was actually in decent shape. It wasn't tarnished or corroded. But it just so turns out that this is the second one in a row that IC2 was taking out the vertical IC. But the story doesn't end there. This capacitor's here because when I grabbed this, it was so hot. I noticed the capacitor was almost boiling hot too, and that's just because it's part of the circuit. But I thought the cap might have been bad, so I changed it. It didn't do anything. So this is the second 7000A in a row where IC2 was causing collapse and taking out the vertical IC. But the story doesn't end there because I put one in from a donor chassis. And that fixed the problem. I put a new vertical IC in there. I put a new IC2 in from a donor chassis, and I had full deflection. The vertical collapse was now fixed, and it was caused by a bad IC2, which again was taking out the vertical IC. But like I say, the story doesn't end there because this donor IC2 that I put in had a problem where I couldn't get horizontal hold. I could not get the image to lock on horizontally. When I tried, sometimes when you have H hold where it won't lock on, your horizontal position needs to be adjusted, because if the screen is adjusted too far right or too far left, it can cause the horizontal hold to not be able to lock on. So I tried to adjust the horizontal position and it did nothing. I could move the pot all the way up and down, up and down, up and down, and the screen did not move. So I followed the traces from the horizontal position pot, and you'll never guess where they go. It goes right to IC2. So the donor IC2 that I robbed from the donor chassis must have had a horizontal hold problem, and that's why it became a donor chassis. I bought it, all these donor chassis that I have are ones that I bought in a lot of, untested, non-working chassis that have already been picked clean and stuff like that. So it turns out that that was probably a donor chassis because it had a H-hold issue that nobody was able to figure out. And I just happened to rob a bad component from it. So I robbed yet another IC2 from another donor chassis. I put that in here, and check it out. Voila. So, yeah, we had this already had a cap kit in it. I went ahead and did a full reflow inspection. Everything tested good, of course. But we ended up having a bad, the collapse was caused by a shorted vertical IC, which was being killed by the bad IC2. And then the replacement that I put in got taken out by the bad IC2. And the replacement IC2 I had put in was causing H-hold issues, so I had to get another IC2. So in all told, we only had 2 bad components. But this bad component was the cause of taking out another component, and this one was bad from the donor chassis, and this ended up probably being fine. So we only ended up having 2 bad components originally. But yeah, after changing those out with doing all the stuff I just described, it's working. So yeah, let's go through and see if we have color bars. Yep, we got RGB. Yeah, it's a bit stretched here. If I do vertical size, it's a bit stretched, but I don't think that this is, the 7000A likes a particular, we've already figured out, I think the last time I worked on one of these was a 19-inch. I think the K7000A likes a little bit different readings when it comes to vertical size, because this is actually a K7400 chassis, I'm sorry, tube and yoke. This is actually a 7400. So I'm not really worried about this so much because I checked to make sure all the caps are correct and everything. I think this is just a byproduct of the fact that this is not a dedicated 7000, and the 7000A likes a little bit different readings on the yoke. So I'm not too worried about this. But the main problem has been resolved. The collapse has been resolved. We have now a working chassis. I got, the color is not that great, but I'll do the white balance and everything. Like I say, it doesn't really matter when I do all these adjustments because it's not staying on this tube. So there's not really any reason for me to do any of that. But I like to go through just make sure that we have good colors and everything normally. So, all right, well, there you have it. Bad IC2 that was taking out the vertical IC. So You know, very rarely will it ever actually be an IC2. That's two 7000As in a row that the IC2 was killing the vertical circuit and causing collapse. Now, I can probably count on one hand the number of times I've had that happen. Now I've had it twice in a row, but it's probably no coincidence that it's a 7000A versus the standard 7000. I don't recall ever on a standard 7000A vertical collapse being caused by IC2. And I'm sure it's possible, but I've never seen it happen that I can recall. Almost always it's the R91, 92, D13, D14, or the IC or something there in between. But I've never actually, I can't recall ever having the IC2 be the cause of the collapse. But in this case, twice in a row on the 7000A, that was the problem. So we'll go back to here. So yeah, I'll do the white balancing, color balancing, everything, just to make sure we have a good looking colors and screen and everything. But for the most part, yeah, the problem is solved. So hopefully you learned something. I know I did. Every time we do this, there's something that we learn together. So I appreciate you watching. Thanks very much. Stay tuned. More stuff on the way. And we'll see you then. All right.